Hi, Kathleen. How are you doing?
I'm pretty good, Adam. How are you?
Maybe even better. So, how is the weather in your country? You are in UK?
I am in the UK. Yes, I'm in Bristol, which,
Hmm.
for those of you who are not sure, is west of London. If you go to London, everybody knows where London is.
Hmm.
Head west 200 kilometres, and there it is. If you fall in the water, you've gone too far. It is grey. It is grey and cold today, and has been grey and cold for the last few days, and it looks to be set to be grey and cold for the next few days. So,
Next
yeah,
few years.
consistent. Yeah,
Okay.
for the next few years. Yeah, actually, that's true.
So, did you listen to any of the AHEX FM episodes so far?
I've sampled a few. I've not gone into
Okay.
anything with
So
that.
the question won't surprise you. So, what was your first computer?
My first computer that I actually owned was a Sinclair ZX81, and the Sinclair Sinclair computers were kind of cheap home computers in the UK, and I think in some other countries they were sold as Timex, and it came with a staggering amount of memory, 1K. And it was programmed in BASIC, and it had a very basic, and there were a number of interesting shortcuts that
Hmm.
the hardware took. But yeah, that was my first one, and it was black and white.
Hmm. With black and white? Is it the rubber keys, right?
Yeah, the one with the rubber keys were the Spectrum. That was the next generation. It was not as good as the rubber keys.
Oh.
It had it had a it had a kind of touch based keyboard. You would push down on things, and it felt more like a kind of 1970s, 1980s game type thing.
I
And
never saw this. I never knew about
yeah,
that.
yeah. So the Spectrum was probably the one that was more popular, and Spectrum because it had color. And it prided itself on being able to have color. It's an interesting compromise on 8-bit color. And it had the rubber keyboards, and it had more memory. That one came with 16K. But before that was the ZX81, which was a successor to the ZX80. And as the name suggests, these were all based on the Z80
Hmm.
microprocessor.
Hmm.
So yeah, that was the first one I owned, the ZX81.
And why you got it, or what you wanted to do with it? So this is the question.
I don't know. I just wanted to do things. At school, I tried a ZX80, and I tried a couple of kit home computers that were made up. There were a couple that were around at the time,
Hmm.
6502 or Z80 based, and I just found it kind of interesting and fun. And there were kind of a small group of kids at school who were into programming, and it was a sort of a little computer club, and nothing very organized, but it was just kind of interesting to try and do stuff. Sometimes it was interesting to try and just just mess about, just see what you could get the computer to do. Sometimes it was graphics, sometimes it was computational. You
So
know,
not gaming, so really programming.
I did not. Yeah, I did not. It was not really a gaming computer. There were games for it, and some people bought them just for the games. But actually, in that market, you were competing against dedicated games machines, the Atari and so on. So I actually bought it for programming. That was my primary motivation. So I guess I had a very narrow view of what you wanted to do with this stuff, and I was very surprised. It was, oh yeah, I bought it for games, and I'm thinking like, well, why would you do that if you're not going to program them? Because I didn't think of it as a games machine.
Hmm.
So I did program games.
And how
Nothing that I
old
ever.
were you back then? So you bought it. You bought it?
Yeah. I was a teenager.
Okay.
I was at
Okay.
school. Yeah, so I was. So yeah, I was. So I did make games, but I think I shared them with a couple of friends, but nothing ever major. But it was a step up from using a programmable calculator. Whereas these days I wouldn't say that. Programmable calculators are incredibly cool these days. They run Python and all kinds of stuff. But back then, a programmable
Programmable
calculator.
calculators run Python right now.
Yeah. Modern.
I mean,
Modern.
the real hardware, because I thought they are no more that sophisticated anymore because no one uses them.
Oh well, though the point is that people do use, or they want from them, is much better. The traditional programmable calculator that has only a few instructions that you could put in. No. My younger one got one for when they were at school for their A levels when they were 18, and they are genuinely programmable in a full sense. Can do graphs and all the rest of it. So, in other words, people tend not to use calculators, classic calculators, but the fact that you can now have something that is programmable and convenient and small and not your phone, because a phone is the thing everybody pulls out if they're going to use a calculator now, or they just go to, they pull up a Google page and put in a calculation. But if you're going to do it consistently, or you want a little bit more, then having something that's convenient and designed for that, as opposed to a phone, is quite useful. And so modern calculators at the top end are actually quite cool. The only reason I know about this is because my kids got them, or said,
which brand?
Casio was one of the
Casio.
So Casio. I'm pretty sure that come the 25th century, Casio will still be going, and people will still be using something that is a Casio calculator, although we might not recognize it from the 21st century perspective.
This is cool, because I thought, if you do something with calculations, you will end up using computer anyway, and with calculators outside, there's you cannot copy and paste stuff easily. So I thought, but it's an interesting point. It's like a power.
But exactly. It's kind of, if you think about what you want is something that is around the convenience of a phone. But if you're in a lab, or you're just out and about, you want something that's better than a phone, more on my phone I've got a Python interpreter, and it's an absolute pain to use simply because of the form factor, because it's not designed to do that. It's the touchscreen is not designed for lots of entry. And so if you actually want to do something consistently, or you want to just say, I need to apply the statistics function, so obviously it's got a lot of built-in stuff as well, or I want to graph this, and there's a lot of cases where people would want that, but a laptop is perhaps a little bit bigger than they want at that point. So so there is still a niche, or there is a space in which calculators exist. But what we have defined as calculators has moved. And, obviously the usual comparison applies when people say, a modern calculator is just like, that's not just more computational power than they used in the Apollo capsule to get to the moon. It's more computational power than the whole of NASA had. But that's the kind of standard comparison. But that's going to be a moving target. There will always be some kind of case for something in that form factor that's not full keyboard, and perhaps there's something that we're going to change over the next few decades in that. But
You are right. It doesn't make any sense to have calculator in the phone, because if you think about this, the design is completely wrong. Why you should emulate, keys in a phone? I would say something like, I don't know whether you're aware of the Apple Notes, with where you can write down the formulas and they are calculating, is a way better design than trying to replicate a physical calculator on a glass screen. It doesn't make any sense.
Yeah, and the calculator's fine. I'm running an Android phone, and the calculator on that, in fact, the calculator on that does have an interesting feature, is that it's relatively non-lossy. In other words, the problem that you normally get with floating point rounding mostly has been solved. A group actually sat down and said, what are the expected calculations, rather than surprising people. And that's quite interesting. But from a general point of view, if I just want to add a few numbers, or somebody wants to divide up a bill at a restaurant or something like that, absolutely fine. And I can switch it into, a kind of scientific mode or computing mode and do various things. But to do it consistently, it's funny, because when I find I'm about to do that, when I'm sitting at home and I'm in front of a keyboard and I'm just about to get that, I'm just like, no, why am I doing this? I will either type something into the Google calculator, or more likely I have I'll keep a Python shell running. Just keep a Python shell running and use that, because you can. That's much better, because I might as well take advantage of the form factor that I've got right in front of me. But I end up not using a calculator in the classic sense. The minute I need to spend more time playing with numbers, it's just I'll put this in a list and process it and do whatever. But I can't do that with traditional calculators.
Back to your Spectrum. You started with BASIC.
Yes. Yes, I did. So I programmed the Spectrum in BASIC, and then I learned some assembler, and I already knew some Z80 assembler.
How you learned assembler?
trial and error, but also somebody had, so it's one of these things about the small group of people at school, is that people would, obviously there's no internet back then. And it's just a case of like one person discovers something, or they read it in a PC magazine of some kind, and then it kind of goes around by word of mouth in these small groups. Or you read the magazine, oh, that's interesting. And the two processors that people would use back then, Z80 and 6502, somebody actually had a 6502 manual. I don't know where they got it from, so you could read all the codes there. And so it was more a case of just doing that and experimenting and mostly getting things wrong. But then the things that you were making were much smaller. By definition, you had less memory, but also you were less, as a teenager, you're going to be creating smaller, very silly programs. But normally it was to do with, if you were doing that, you were normally doing something on screen. Mm-hmm. And so it was something to do with that. But the interesting thing is I have actually, during that era, it's not just that I learned assembler, is I also learned machine code. I did actually know, as in, it was one of those things I could actually type in the hex for various things. All those memories are now dead and buried, and all the rest of it. But back then, you did know that, because it's just like, oh, if I just push this into this, if I poke this into this part of memory, then this is what will happen. And so I actually learnt machine code, and then learnt assembler, then learnt basic, and then tried a couple of other things, but with really not much success. So, for example, Forth and things like that. And pretty much was stuck at that level for quite a few years. I think I touched on Fortran at university, and then discovered that maybe I could actually get a career doing software development. That was not my.
And what was your most usable or interesting application you wrote on the Spectrum?
Application is a strong word. I think the things that I remember most, having the most fun trying to do, were simulations, and I mean real world simulations, as in, what happens when a volcano explodes. So just seeing particles jump out and then adding friction to that and so on. So you end up with this kind of halo of material kind of just spanning very, very slowly on the screen. One of the other ones that I had a bit of fun doing was trying to do stars, n-body problems. Never got quite to the whole of galaxy, but n-body problems. Trying to get that to work. And obviously you're just experimenting, and you don't know about using different world frames and things that are natural these days for simulations and games. In the games industry, the idea of like, I'll have a set of world coordinates and I'll translate them to the screen. That was not intuitive then. So sometimes you'd be sitting there and going like, well, something happened and it happened really quickly and it shot straight off the screen. Or everything's too close together and it just collapses. I did not do black hole modeling back then. But that was the most fun I remember doing. I did a couple of game things, but I don't really remember much about the games. But in terms of the simulations, that was quite fun. When I used a couple of other computers that I used at the time, but I didn't have one. The BBC microcomputer was quite a big deal in the UK in the 1980s. And I learned how to program that. That was one we had at school, and that was great fun. That had a much more structured BASIC. You could properly define functions. You have blocks.
Go sub. Like this was my.
Go sub was the kind of the classic, but that was in class. That was all the other BASIC. The idea was that you actually had procedures that you could call.
Whoa!
Just like, whoa! You didn't have to use line numbers for as the kind of the anchor for everything. But for that one, I remember playing some driving games or creating some driving games and just sort of having the view of the horizon rolling towards you and this kind of stuff. So it's kind of nothing very cool, but very, I think, visually oriented was what I did, which is kind of interesting because ultimately when I started in software, I did embedded stuff and I didn't really do much UI stuff or GUI stuff or even game stuff. But yeah, that was kind of what I would end up doing and just trying to apply, I don't know, stuff I'd learned at school in physics lessons or in art lessons as well, actually, perspective, how to draw things in 3D.
Mm-hmm. Interesting, but I mean, for a teenager, it's crazy hard, to implement simulation, whatever. I mean, you spend countless hours, maybe, right? With that.
Oh yeah, Oh yeah. I think that's misspending of part of my youth. Definitely, it was. It
But
was.
still good memories, right? It's not like waste of
Yeah.
time.
Oh
Yeah,
no, it wasn't a waste of time. No, I learned a great deal, but I also found a sort of a great deal of I don't know. It's a place you can direct your passion. It's just a
yeah.
it's a case if you've got a lot of spare energy and passion, which I guess teenagers do. It's the ability to direct your energy at something. I spent my time also reading books, going to the cinema, this kind of stuff, and hanging out with people. But it was just like this was a very creative personal focus. I guess also in that era, I used to draw a lot. Art was a big thing for me when I was younger, and so the visual side, I guess carried over. Although I can't say anything that I ever did artistically ever obviously influenced what I was writing on the computer.
Okay. What was your next computer? Also, how long you had the ZX?
So yeah, I went the ZX81, then the ZX Spectrum, then there was another Sinclair computer called the QL, which I had access to, but I don't think
QL. I had an Amstrad. So I had actually an
Oh,
Amstrad
okay.
128. Was it
Right.
is QL better than the Amstrad or?
That's an interesting question because I think the Amstrad might technically have been better. The QL was a really quirky, odd machine. It was certainly more powerful. It had a number of ideas. I always wanted to have a BBC Micro, but never did. I always wanted to have an Apple II, but never did.
I wanted to have a C64 and also never did. So this was.
Yeah. Likewise, there were a whole bunch of computers, and I learned enough about them, and I had friends who had them, and so it was a case of like, I can use that. But I think after the Q, I did not own a computer until. I did not own a computer until I was working, and in fact, it wasn't even my first job working. I think it was. I'm trying to remember. It was a 286.
Okay.
And I got that, and I think it was around the time I did a master's degree, and I think it ran a 286. Might have been a 386. And I might be getting my computers muddled up because I know that after that I got an LNX, then a Compaq. As kind of tower machines, but I did have a PC, and that was kind of a hand-me-down. That was from my father had bought a computer because he thought that would be useful, and then discovered that it wasn't. So I ended up using this computer. So I had that for my master's degree, and that was very helpful because I was able to. I actually, I had a C compiler on that. And obviously, I had an editor, so I was able to write my master's thesis in note form, in plain ASCII, and then use the power of floppy disk to take it to the university, and then word process it, or rather, no.
So you survived university without a computer?
Yeah, my first degree, I didn't have a computer. In fact, I barely used. I used computers a few times. I did a physics degree, so we had access. to
Physics. Okay, I thought you are a software
No,
engineer.
no. So my master's degree was actually software,
Okay.
with parallel computer systems. But my original degree was physics, and so we had access to computers. But but it wasn't heavy access. It was a case of like, here's a thing that is plugged into a sensor, and you can take readings. And that was typically, it was an Apple II. Or 2E, or it was a BBC Micro or whatever. And I just, myself and my lab partner, I always ended up doing the programming side because we weren't really taught much about programming in the physics degree. There was a kind of, I think it was a Fortran module.
And was it interesting to you, physics? Was it, you enjoyed physics or?
It was interesting to me. I think it was when I arrived at my physics degree, I didn't want to do it. Let's put it that way. I think it's a thing that I find, I have always, since being a child, I'm always fascinated by science, and I continue with that fascination. But that was during my degree, I got much more interested in psychology, philosophy, and interestingly enough, AI, but as it was back then. And it was ultimately that I finished my physics degree, and it's like, well, I don't know what I'm going to do. I ended up with a programming job because a friend of mine had said, "Oh, I've just been for a job interview. Kevlin, I don't think it's the thing that I want to do, but you might be interested in it." So I did. It was a small software house based in Bristol, and I got really interested in stuff at that point. That was my main software education. My boss had a wall of books, none of which were relevant to what we were doing. They were on different programming languages, paradigms and technologies and all this kind of stuff. Only a subset were actually applicable to the kind of stuff we did. But I would grab a book and take it home and read it and become basically self-taught. And I got so interested in this, and it converged with my interest in philosophy of mind and AI, that I started thinking, maybe I want to do an AI degree or a cognitive science degree. But this was around the time the world was changing. The world was changing towards neural networks. In other words, the old paradigm of the classic view of AI as we will instruct the computer with rules and things like that, rule-based engines and stuff like that, typically written in Lisp or something like Prolog or these kind of really classic languages. The world was changing. The neural network approach was becoming the way of thinking about it. And that actually ultimately informed why I ended up doing parallel computer systems. I instantly stopped doing AI at that point and went off into software engineering because I actually found that more interesting. And I discovered things like the actor model and all the rest of it way back then. But it was, for me, that was what triggered my interest. So my real interest that I started discovering is just like, yeah, physics is interesting, but, what about the mind? What about philosophy? What about the universe, or another way of looking at the universe? But also, what about artificial intelligence being this kind of idea? And I'd also very influenced. In my adolescence, I read a book, Gödel, Escher, Bach by Douglas Hofstadter, and that was kind of mind-blowing. I plan to reread it one of these days. My original copy is falling apart, so I bought a second copy because it's also a really interesting walk through mathematics, computability, paradoxes, and it's also presented in a really interesting way. And I read that before I kind of did any computer science. And I also think that if I reread it now, first of all, I'd be able to bring a very different perspective. But also, the world has changed. So I think it would be very interesting from a historical perspective to see how the book has changed with time. But yeah,
what's interesting
those are my interests.
During my study, I also learned, I had neural networks. But back then, they were already old. So they were like from the 60s, right? So interesting. And for me, I don't even know whether I associated neural networks with AI. Kind of, because I knew that they are able to learn with the matrix multiplication, and I was fascinated by that. So this is like backwards. So what I like about that is actually backwards. You know the result, and you have to adjust the metrics until it works. This is what I like. This is what it was like somehow you make the computer work to achieve something. So this is what I like about. So not like I'm telling the computer something. The computer does something and try to find the parameters.
Yeah.
So
I think the thing about the old thing is that certainly perceptrons as an idea in the 1960s, but that was the difficulty of doing multi-layer networks. That problem was not really cracked until probably the 1980s. Rumelhart and McClelland, I think it was about 1985, 1986, and the ability to back propagate.
Exactly. They had a problem.
The back propagation was the big deal. That's why that was suddenly changing. And at that point, we were still on the Moore's law conveyor belt. And so it needed enough, it needed a mix of the right things to come about. And it's just like, there's just enough hardware to start doing interesting things. And we know the mathematics to do it. And so that became really interesting. And what I did in my degree was that you had a distributed system and you used parallel computation and all kinds of stuff, because matrix manipulation is very good for this. So compared to modern AI, I mean, I kind of joke about it as being shallow learning rather than deep learning. But it was, for me, I could sense that things were changing around that time. And so although I had a real interest in like the classic AI kind of view of the world, this was what really looked like the future. And then I kind of, as I say, I took a hard left and disappeared off into software engineering, because I suddenly discovered, I really like programming languages and paradigms, and that was the way that I got in. So I got in, Fortran assembly. So it was basic assembler, Fortran, and then I learned C, and the world changed for me. It was just like, this is the gateway. This is the thing that makes everything different. C and Lisp and languages like that. It was just like, right, this is interesting. So,
and what did you do in your first job? With the boss with the wall of books.
Oh, my first job. It was a mix of stuff, but the bits that really linger it was a lot of there was a lot of factory automation stuff.
Okay.
I mean, I did work on one business system that was some kind of purchase ledger thing, which I don't really remember much about. There was a 4GL involved, which was disastrous. Okay. But the main stuff I did was for an optics factory. And by optics, I mean the lenses that you have on a pair of glasses. And they had a whole automated system. And so there was a lot of data in that. And some of that was the automation side of the factory itself. And then there was another device, a handheld device for doing barcode reading in warehouses, and I worked on that. So so that was really, to me, some of the more interesting stuff that I remember. There was some dull bits, like I say, the purchase ledger work, but the interacting with hardware and this kind of low level kind of thing, I kind of discovered I quite like that, and in some senses, I feel it was close to my home computing start, and it's something I still kind of hold on to now. But it was that whole idea of machinery, and then in my master's degree, I actually I created a virtual machine, which is I thought everybody was doing this because everything that I was reading said, "Oh yeah, VMs." It was either P code or whatever. Really, really big, and this was pre-Java, so it was just quite interesting. It was a retargetable.
This? I mean, what means
invent? I didn't really invent it. It was what I did was. What I was interested in is I had learned about this thing while I was working. I had learned about this thing called object orientation, and the funny thing is that we were being taught. So this is where I worked. We had somebody from the Jordan company. So Ed Jordan and a bunch of others in the 1970s were responsible for coming up with ideas like structured analysis and structured design, and so. My boss had thought, maybe, instead of the chaotic software development we do, maybe we need to have a little bit of discipline here and learn this stuff. But this was the funny thing. The guy that taught me, and I ended up meeting him again years later because I worked for a training and consultancy firm, and he was one of the people there. But this guy, Phil Sully, he was busy teaching us this stuff, but he was much more interested in object orientation. So he kept kind of saying, if you do it, and at that point he said to me, I started asking him questions about this in the break, and I suddenly realized this connected with a lot of the other stuff I was reading on the bookshelf to do with modularity, abstract data types, it was Ada, Modular 2, and all of these things. And he was talking about all these ideas, and he came in with this magazine one day that just was filled with articles on this stuff, and I just photocopied the whole thing. And
was it Dr. Dobbs' journal, or what was it?
No, it was actually it wasn't a Dr. Dobbs. I didn't discover Dr. Dobbs until I think after my master's degree. Mm-hmm. This was it was Ed Jordan's journal. I can't remember what it was called, but it was and it was just it was a special issue on object orientation. And I started looking at this stuff and then discovered there was this language C++. We just got Turbo C, so maybe we could use Turbo C++. So started really looking at this, and this was absolutely fascinating to me. When I went into university, when I went to do my master's degree, I started getting interested in objects as a metaphor for things on a network, and really kind of thinking about process and object unification. And I stumbled across this thing called the actor model.
Not agents, because back then there were agents I think.
Agents were becoming popular, but no, the actor model, I stumbled across the thing because a machine had it installed, a thing called ABCL. It was a language, the alpha language, and it kind of joked itself being an object-based concurrent language, but actually it was an actor-based concurrent language. And it was based on Lisp, and it had a lot of ideas in it, and it was just like, wow, this is really different. And so I started reading up on actors and object models in the network and stuff like that. And that's the path that I then took. I was really interested in that. And I guess I applied it for a few years after, or things related to it, but my work took me elsewhere. But that for me was a really intense period of interest. But the whole idea of the virtual machine thing is I kept reading things where people say, oh yeah, we've got this retargetable thing, and what we've got is a high level language, a lower level abstract machine, and then we retargeted onto actual physical hardware. And so I ended up creating a virtual machine for a Lisp, effectively a Lisp machine that happened to be biased towards actors, and a simple instruction set. And I'd just been learning about instruction sets, so I had a reduced instruction set computer. I think it was about 30, 40 relatively high level assembler primitives. And I could run this on Sun workstations, which actually have support for networking, concurrency, and all the rest of it. I could run this on a variety of Sun workstations, but also PCs running DOS. And so I could retarget the C to run in these two different environments quite easily, but write this high level stuff. So that for me was very, very interesting. And I thought this was something the industry was doing, but that's a classic bias. When you get stuck in a bubble like academia or anything like that, you start reading things, you think, oh, this is the way the world is. And then you come out into the world and you realize nobody is doing that at all. And it's a handful of people. For me, that was very interesting. A retargetable object-oriented language based on a virtual machine all this sounds really, really familiar. And so it's kind of like when as the 1990s played out, I sort of thought, oh, okay, this is actually a big deal. And, people are making money out of this, and there's something here. I just thought it was a thing that people did. But actually, it turns out to have been a different vision of the future, and one that I had taken for granted but undervalued. I just didn't appreciate actually what was going on in the regular software development landscape.
So back then you already had the inbox and you exchanged messages and they apply to the object on the other side. So what you did is kind of events, and you sent events between objects and they were reapplied in,
You basically sent an asynchronous message to another object. It goes into a queue. Mm-hmm. The thing that ABCL also had was an expedited queue. So you have a high priority queue, but a regular queue. And then you basically match, you pull something from the queue, you pattern match according to a script. That was the wording that was used. And you pattern match on that, and then you handle it. And you can correspond an entry in a script or a pattern to a script. You can correspond that to a method in a much looser sense, so a much more reflective kind of idea. So that was the idea. Yeah. So, and that was done, and it was all, I guess, basically we think of it as being a fiber-based approach. I did everything within, the multitasking was not preemptive, not properly preemptive.
But this was parallel computing. So how many machines did you had in the lab? So what was your task? So
that was the thing. Is that, in fact, when I said retargetable, I should have said further retargetable. What we had is we had a whole bunch of Sun workstations, but we also had a lot of transputers. Now, transputers were made by Inmos in the 1980s. They were very, very parallel hardware. In some senses, very much ahead of their time. But they also came with a programming language called OCCAM, which is...
Never heard about it. OCCAM.
OCCAM, yeah. So like Occam's razor, that's why it was named for that. And OCCAM was based on CSP, Tony Hoare's communicating sequential processes. But it was a it was a super structured language. It's the most block structured language I have ever used. Everything else with it didn't have curly brackets. It used indentation as significant. So I got a very early exposure to that idea. But it had a very general idea of computation, in the sense that you can have a block, and the block was either in parallel or in sequence. In other words, you treated sequence and parallel as if they were first class. And so if I give you, so therefore a for loop was simply a repeated sequential block. If you think about it, that's what a for loop is. I've got a sequence here. I'm going to repeat it from I equals 0 to whatever. I'm going to repeat that block of code. It's just that I will be different. It'll have a different value in each occurrence of the block. Well, what if each line of the block is instead executed in parallel? Then what you have is you've created an array of computational nodes, an array of processes. And you use channels to communicate between each of them. So that was the native language, effectively, of the transputer. But there was also a C compiler. So when I wrote my code for my virtual machine, I could run it on Transputer's Intel processors and Motorola. That was the Sun stuff. I don't think we had any Spark stations at that point, but if we did, then it probably ran on those as well. So for me, that was kind of interesting at that point. But yeah, OCCAM was a very elegant language, but targeted very much one piece of hardware, which is why many people are not. It didn't escape into the wild. It's why you don't know about it. It's why most people don't know about it. But it was a fascinating piece of language design that was, in some senses, way ahead of its time, and we can still learn things from it. It was developed originally in the 1980s and then 1990s. And I look at some programming languages now and think yeah, you could do that, or you could learn a few lessons from the past. There's some really interesting ideas.
Yeah, it was always true, actually, right?
Yeah. So that for me was, but again, for me at that point, now when I think back on it, I look at it and think, oh, well, when I was young at that point, and so didn't know that certain things were not normal, that these ideas were old ideas and new ideas were new to me. Let's put it that way. And so I treated them fairly equally.
What was your use case? So you, of course, this was your master work, but you had some use case, an example, or you had some test data. So what you wanted to get something to test?
The goal, the goal of this was it really was to just explore. Initially, it was to explore different paradigms and their suitability for parallel and distributed and concurrent computation, and then narrow down on looking at this kind of actor-based model, which I was viewing through the lens, although we can view it functionally, I was viewing it primarily through the lens of an object model. And it was simply to create something that did that. That was the goal.
But you had some test data or sample data, or?
Well, it wasn't I had some sample programs and I did some things, but it was really just a proof of concept of the idea. Yeah. Well, I think the stuff I learned so in other words, that's kind of like left behind in history, but I will say the stuff I learned from that proved to be useful in many different ways. In my as I worked in early threading, I did a lot of threading stuff and real-time systems in the 90s, and that for me it helped me, rather than get lost in the ideas that people often do, which is like, hey, we need to lock everything. It's just like, no, we should think of our threads as if they were processes, and then talk to everything else through queues rather than trying to mutex everything. And you can actually see in the Java space, it's interesting because I've got kind of like a sequence of books on my shelves. You've got the kind of original Scott Oakes and Henry Wong Java Threads book. And that's all the kind of old school style approach to threads. Hey, we've got threads. We're sharing everything. Oh my goodness, we have problems. We must lock everything. There must be synchronized blocks everywhere. And then you've got the progression into kind of like, the Doug Lee stuff and Brian Getz, and where you're actually saying, maybe you need to know some of these things, but actually we could work at a higher level. We should be thinking in terms of things that message each other rather than, oh, look, I'm a flow of control and I'm going to mess with your data. It's like, treat the data as something you're not allowed to touch. In other words, treat everything as if it's processes. And try and come up with a discipline for interaction. What is your model of interaction? So a messaging, for example, use of queues, or just like simple letterboxes, one-place queues, and futures and stuff like that. These ideas were that I found that useful, even though I was often programming in C or C++ and dealing with raw threads. But even like when hitting Java, is that people were kind of still programming as if they were working with a C API. And also immutability. A lot of people did not get the immutability message. And that's one of the curious things I found in OCCAM, is that OCCAM had a very strict, it's the most brutal,
what you mentioned ever about OCCAM, what it reminds me on the templates. Are you aware of Rife web framework in Java? Right?
I know, I've heard of it, but I couldn't tell you anything about it.
It's Hert Bevin, and he created a template model, and it reminds me a little bit on your you have to take a look at Rife 2. It was very popular, and it used more or less continuations behind the scenes as well.
Oh, yeah.
And I just remember, because very early in Java, I heard about that, and then I was really curious how it works, and also had on the podcast, and I was very interested how the templates are actually working, because in Java templates is, we have JSPs, we have JSF, and this Rive 2 is a really interesting approach. And what you actually stated with the how it's called,
OCCAM, yeah.
OCCAM. Maybe there is a link between, right? So this is interesting.
I think more people have been inspired by the CSP thing. Every now and then I kind of see somebody sort of making reference to this in like, oh, we created this framework, it was inspired by CSP. So I think that so the ideas, some of the OCCAM ideas have found their way into either frameworks or languages, but normally not directly from OCCAM, but it's parent, if you like, the formalism CSP, which is nice to see. I found knowing a bit of CSP allowed me to reason about windowing in Microsoft Windows and Motif, thinking of different windows as if they were communicating processes is actually a really helpful way of trying to understand the messaging in GUI things. When I came to do GUI stuff, I remember being overwhelmed by, hey, there's events everywhere, and we've just got these big switch handlers and stuff like that. And then thinking, if I think about it as communicating processes, it's actually a much better model, and the messages become a little more real, and there is a concurrency there, obviously one negotiated by the framework, as opposed to being a preemptive model. But actually the thinking model I found really, really useful. Treat each window or unit as if it's encapsulated. And it allowed me to actually think through the message mess, as it were. And
so I was also fascinated by objects. So at the end, I even saw tables as object in the database. Like, at the end of the day, there's just data, and you could use SQL to manipulate the data. This could be methods of the object, Yeah. And I tried to explain it to my professor, but he couldn't get the idea. As I know, it's wrong. It's not an object.
I think that is always the problem when talking across a paradigm gap. I mean, that when talking across a paradigm gap, you do end up with that, because although sometimes you may have suddenly been grabbed by something, and then you try and explain it to somebody, but they're able to reframe it in terms of what they're thinking. But the problem, well, in one sense, that's an advantage. They don't necessarily see the bigger picture. And so I tend to find that with each paradigm that often that's our case. Any paradigm is a language for thinking, if you like. It's a way of looking at the universe. It's you say, hey, here's the things that are important, and then everything else kind of hangs off that.
Exactly.
And it just changes your worldview. And whenever we look at different paradigms, you're always talking to people who have a very different paradigm experience. And often people will walk away with a slightly different, a different understanding than the one that you had at that point, because you're very excited about one thing, and and it's just like somebody walks away going like, oh, okay, this is what it is. And for a lot of people, I know when I first looked at object orientation, for me, the most important message was actually modularity. But that's because I came from a Fortran and BASIC background. For me, the thing that hit me hardest was modularity. Then I started understanding a lot more about what was going on. It's like, oh, that extends into encapsulation organized around a data type and strict protection of state. And I started, oh, okay, it's not just modularity. There's something else. But the first time I'd seen that, and people get it. I see it with people messing about in Java when they're looking at lambdas. They go, oh, I'm doing functional programming because I've got lambdas. And it's just like, actually, no, not really, because a lot of programming languages have that construct, and they would never. It's a first, if we go back to classic procedural languages, the ability to pass a piece of code to be executed, you find that as a primitive in object-oriented languages. There's a kind of a joke I said I did a talk over 20 years ago where I said, I stood up and it was a Java talk, and I said, Java's not an object-oriented language. And I made the case for why it's not an object-oriented language. And I said, because I cannot treat methods as if they were objects. I said, the reflection API doesn't count, but I cannot just pass you, here is a thing I want done. It's just like, that's a fundamental idea. Why can't I pass that? Or a block of code. A block of code is a thing. You find this in Smalltalk, you find this in Lisp. And it's just like, it's a first-class thing. I should be able to give you a piece of code. Now, as of 2014,
I had a fight
Java
with
8,
Smalltalk developers. They always
Yeah.
wanted to have it. I was like, okay, come on, because we had to migrate from Smalltalk to Java. We had to because of support issues, and
Yeah.
they really like Smalltalk, and we had always the conversations about meta programming, blocks of code. Like, show me
Yeah.
Java block code. Yeah. The most similar thing was inner class back then. I remember.
I was about to say inner classes,
Yeah.
And I remember just suddenly being able to translate all of this Lambda style stuff that I have into inner classes. But my goodness, the amount of curly brackets and stuff that you
and
had
I showed
to
them
do.
inner classes, and what they immediately did, they created a hierarchy of inner classes, which was like a meta programming stuff, which reflected, it's okay, maybe it goes too far, because this is just a boring crud enterprise application, but it was fun back then. So what happened after your thesis? So you must have worked with VM.
Oh, I just ended up going back. I mean, from that, there was a fork in the road. There was a road where I would have ended up doing, I don't know, PhD and just doing research built on that, trying to map to physical
really?
systems.
So you also have a PhD?
No, I don't. That's the road that I did not take. That is the road not taken. That there was a path there that might have led to that, but actually, but it turns out they wanted more hardware focus, and I'm just like, by that point, I am definitely a software guy. I do all of these high level abstractions, so I don't have to do the hardware, and so my interest in that was very, very different. So that didn't happen. I basically went into, I went back into, I guess, science and simulation programming. And then I went back, and then after that job, I went into more back into real time stuff, a different role, and that was kind of like back end network. And I started actually being able to apply some of these ideas, interesting enough. But C++ real time operating system, but with high concurrency and message based asynchronous communication, and that so that took me into that world. I ended up working in a bank for a short time as a contractor, again working on a middleware thing, and that was kind of my area of interest before I then went into training and consultancy, and then got a very different view of the world from that point of view. In other words, that kind of shifted me into perhaps having to appreciate the broader spectrum of what's actually going on in the software world, and that and different people's needs in those senses. But again, all the programming language and paradigm interest actually turned out to be the right obsession to have.
Okay, and so you learned about Java. How you learned about Java back then? Because so far you just spend time C++ and other
Well, the Java thing is so. Here's the thing that's happening in the mid-90s. It's just like, oh, you can download this. Okay, there's a free language, and it's not open source. So at that point, everything that you could download for free had been in some sense an open source or public domain or whatever, or you were pirating it. Yes. So this is how you had access to other programming languages and other programming systems. And you would go to FTP sites and stuff like that. And then there is this thing from Sun. We're going to create a language, and it is going to be platform independent, and it's going to be objects, and it's just like, oh, we're going to keep the curly brackets because that's familiar to people. So we're going to keep a kind of C-ish feel, which is very unsurprising given that it was Sun. And, in my mind, and I think a lot of people's minds, if you were working with Sun workstations back in the 90s, Sun was pretty much synonymous with the kind of classic, the champion of Unix at that time. So therefore everything was going to be in C or scripty type stuff. So here was something that was available for download, and it was kind of right. Of course, a lot of people were talking about applets at that point. Oh yeah, you can run dynamic content in your web browser. Well, that turned out not to be the right path. But having a general purpose object-oriented language that's platform independent was incredibly appealing at that point, and also relatively syntax light. It wasn't heavy on the syntax. It was strong on the familiarity, because I know whenever I was showing anybody, we just talked about Smalltalk, although nobody ever paid me to write Smalltalk, I did learn Smalltalk. It was a case of if you show people Smalltalk, they kind of look at you and go like, "Whoa, that looks really unfamiliar," and they couldn't get past that. Whereas Java had the right familiarity kind of ground floor. You could get in on the ground floor. You didn't have to. There was not a big barrier to entry in that sense. And the idea I could just download it and run it on either
which version you remember?
Oh, I remember pre-version 1.0.2. So the beta stuff, and just playing around with it at home as well as it was. So at home, it would be on running on a 486, I guess at that point, maybe a Pentium. But at work, there would be some workstation, and that was really quite cool. This whole idea, and so that was it. That was really interesting to me. That I at this point I was keeping my mind on multiple programming languages. So although I had a strong C++ background and a heavy involvement with that C and C++, because I was doing systems programming and real time stuff, the Java stuff from the point of view of what are people doing in the application domain space, and let's put it this way. Although I may have started in BASIC, I had no love of BASIC, and I certainly had no love of Visual Basic. So for me, it's just a case of like when I'm dealing with people who aren't in closer to the hardware, what am I going to be talking? And for me, that was the attraction of Java, because I don't want to be talking VB. It was a simple, I guess as human beings, we like to present ourselves as rational, but there's always a kind of a prejudice somewhere. And mine was around VB. And so that whole idea of like, oh, here's something that offers the ability to be able to express using an object model, concepts that but also not having to worry about some of the low level obsession that you get drawn into with C and C++, but in a way I can talk to people about this. And it means I don't have to be talking VB, I don't have to be talking COBOL or anything like that, and DBase or Clipper or any of these things, which I had a little bit of experience in, but I was not very keen on. So it allowed me. So Java, that was for me the space that Java filled. It was just like, here's how we can start thinking about properly developing software in a more rational sense in this space. So that for me was why I got interested, and just the sheer fascination of just being able to download effectively a virtual machine plus language. The only other time I'd had that experience was with Nicholas Wirth's Oberon system, which is a successor to his modular stuff, but it was also an operating system. And I remember just thinking, I'm getting more than a language here. I'm getting a whole stack effectively. And at that point, for me, that was part of the attraction of Java. It's just like, you know what, maybe this is where the future is. As it turns out, things came out very differently. We didn't end up using Java in the browser, and the world changed shape. But that original appeal was, once I'd taken that path, that was, I've kind of stayed on that on and off. I've dealt with different languages over the years, but it was a case of like that. That was why I got into it at that.
So, what surprises me that you like Java, because Java was 1.0. I think there were not even interfaces, right? So there
were interfaces
in 1.1.
They were in, yeah. Oh yeah. Interfaces were there right at the start. James Gosling put them in there because he was inspired by stuff in Objective-C.
In my memory is that they came later, 1.1.
No. Interfaces were right there at the beginning.
Cool.
Stuff like the clonable interface, for example, that all of these things. But you had the habit back then. Interfaces were used for if you use them for there was also the marker interface idiom. So that marker interface idiom was but also for clonability and things like that. You'd implement an empty interface, and that was that was communicating to the VM or whatever. Hey, this is good. And that was what the role that annotations took on from Java 5 onwards. But no, interfaces were there from the beginning. But in many senses, it was a very raw language. It was it was interesting because at that point C++ was also changing, and there were things in that I remember thinking, because at the time I thought, oh, the amount of boilerplate code I have to write in C++, and that started changing because of the way they did the library and the way they did generics in C++. That started changing, but then I arrived in Java, in which on one hand was cleaner, but there were also things that were incredibly tedious. If you want to write a lot of, it got to the point that just before Java 5, if you want it, I used to start joking that, if you want to be able to write lots of code that does very little, or, you want to be paid by the line of code, Java is the language, because very simple things took a lot of, I have to write everything out in the loop. I have to write all of it. It had not hit that point. Java 5 just started switching the direction of the language to say, you know what, maybe we don't have to say everything, because that was the intention. I think that in the original design, everything's very explicit. Everything has a keyword. And then you end up with this pile up of modifiers, which is exhausting. It's syntactically very, very heavy. And then you get to having to do things with loops. And because you didn't have lambdas or blocks, you couldn't put a lot of stuff in, and you didn't have generics until 5. You couldn't put a lot of stuff into the JDK. So you ended up writing a whole load of loops. I mean, that's the whole thing, is that when I think of legacy Java, I think of lots of code with lots of indentation and lots of loops and lots of ifs. It might as well be Fortran, but it's dressed up with classes.
And the main problem back then was the Java mindset was to decouple from the implementation and from the vendor neutrality, if you remember. This introduced additional layers, which were mostly empty because the abstraction were really bad. So there was lots of dead code back then. It still is in some projects.
Yeah,
but
I think you're right.
The first version was tiny. So the JVM was like 5 megs. I remember you could. It's very, very small. So your main purpose of Java back then was training. More?
Training examples. I got into conference speaking, and if I needed unless I was speaking to a language specific audience, then Java was a good lingua franca. It's just like, hey, here's something everybody can understand. So it was primarily what I was involved in. It was not primarily application development, because I was working for a training and consultancy firm, but that was my kind of a main area of interest in it, and just as kind of like, this is a really interesting direction, but kind of hoping that other things would happen. And you mentioned inner classes, so I was very excited by inner classes because
they happened in 1.1, right? They came later.
1.2, I think.
Okay, inner classes, exactly. Inner classes came later because everyone was excited with the listeners, because
and that's right.
You could implement the listeners inner classes. The interface, of course, had to be there. And JDBC came also later. So I remember this was.
You had all of this stuff, but then again, you. As I think we've all learned, is the case of like, somebody adds a feature and says, "Hey, these are." Here's the intent of these things.
And interfaces were there because I hated them. So what I really liked in C++ were the headers, right? Header files. Yes. And for me, it was a clear and clean separation between the contract and the implementation. And the interfaces were like half done. I couldn't get the point. It's like, why I should do this? I mean, anything ends up having the same thing anyway. So there was no clear, and this is why I never liked interfaces at the beginning. And I understood them with JDBC because with the driver manager, and the connection, driver manager was like the factory, and in the static initializer where the driver was initialized, for me was okay. Now I get it. So there's one class which per reflection creates products and returns them as interfaces. So I'm completely independent from the driver. This was for me a moment where I understood, of course, interface.
Well, and I think that's a. So I just remember it was 1.1 that inner classes were introduced, because it was. I remember thinking it was really early, because there was a whole load of stuff that came in 1.2 that I thought, that's and particularly collections, all of this kind of stuff in 1.2, and it's just like it was really interesting that they came that way round. From my point of view, it's just like, we've extended the language before doing that. The thing that it was interesting to me about inner classes is that they also had some stuff I mentioned in this ABCL language that I was interested in. The way that inner classes would capture the closure of the surrounding class was also a feature I'd only ever seen previously in ABCL. But I think the thing about interfaces, it goes back to what we were saying about understanding paradigms. And when somebody explains the idea, somebody else hears something different based on their experience. And you've just described your experience as doing that. So a lot of people around me were just like, interfaces just feel like abstract class. Either it's the header. So I got two different views on this. One was the one you described. It's kind of like having header files back in Java. So I've got a clean separation. The other one was, it's a workaround because abstract classes, it's for the fact that you've only got single implementation here.
Exactly.
But the thing is, I took a different path on this one, is that I had come through being interested in distributed systems. So I'd seen IDLs, both the DCE IDL that Microsoft then used for COM, and also Corba IDL. And the idea of like an interface as a first-class construct, because you don't know what you're talking to. It's the ultimate encapsulation. There is something on a different machine. It has potentially different operating system and hardware characteristics. So all I can tell you is how we communicate. I cannot tell you the implementation. And so the interface becomes the purest version. And therefore, it's not to do with inheritance and or a workaround. So when interfaces came out, I was ready for them, but a lot of people weren't. But again, it highlights how each person's journey is going to be very different and how people will learn these things differently.
Okay, and that for me, interfaces were natural with RMI, remote method invocation, because because there was the proxy pattern, and it was this interface implemented a proxy, and the proxy talked to the actual was it servant? I think was the name servant, proxy and servant in Corba and RMI over IOP.
That's right. Yeah.
And so from then until now, so you are trainer consultant, and this is nothing changed. I mean, from the
I mean, I've done nothing since the beginning of the century, but I have stayed in the same role. I now work for myself, and that's what I've been doing. It's training, it's consultancy. And it's speaking, writing, doing various bits and pieces, and it's been in that space.
Okay, because what I remember, I think it was 2015, and Matthias Carlson. So we were from Java 1 back, and he said you should visit JFocus, and I say, where is it? Stockholm. I was okay, interesting. So and Kevlin Henley, exactly. Kevlin is also there. It's like, who is Kevlin? I never heard. So there's a nice guy consultant. You don't know Kevlin? It was back then. So no. And since then, I remember, this conversation, and I say, once I will really have to invite you and talk who actually you are, because it's a really interesting person and what you did, and really interesting conversation. And did you ever participated in JSRs, Java Specification Requests, or JCPs?
No, I didn't. No, there was.
But I found your name somewhere. I remember also your name, something with maybe JAX-RS or something like this. No, never.
I've not participated directly. I have given comments to people on various things, or I've done things that other people have sort of said, "Oh, that's in this." So,
or maybe mailing list at some microsystems, because I
might be
your name from some maybe REST or something with Java that you participated.
Probably not the REST stuff in, but I did have there was a kind of a point years ago when before the JCP was created, where it looked like Java might try and take the ISO or ECMA route to standardization, and I've been involved in a couple of things already at that point.
Okay,
and that might be it. But also, I had very strong involvement in the patents community in the 1990s and 2000s, late 1990s and early 2000s. Very heavily involved in patents, and some of the patents that I described, there was a very strong crossover in terms of how Java was growing at the time. And so that there's always the chance that some of that kind of made its way, that you might have come across my name, but I've never been directly involved in JS.
Okay, because I read your name several times, and I also was curious, who are you actually? Because we never, maybe I saw you at the conference, but, but distribution, maybe last topic for today, but what I did a lot is the Corba RMI, remote method invocation, and I like RMI a little bit better because it was better or nicer integrated with Java with less ceremony than Corba. But there were also interesting systems. I don't know whether you remember. There was Genie, Java Intelligent
I
Network
do.
Infrastructure.
Yeah.
Agents. There were lots of agents and egglets frameworks. Then Java Spaces, which was a kind of a distributed database based on Lambda. And Genie was like, the communication between the Java spaces.
Yeah.
And this is where I actually got my ideas, because still, there was the idea of leasing, that you are leasing, the services, and they self-healing. So this was, and it was, the marketing was really bad back then from Sun, because they tried to sell it as I remember, printer driver management system. It's like, you are all crazy, no one will buy it, right? But this was actually, was way better than later SOA, this service-oriented architecture microservices. This was actually the perfect microservice solution, because even load balancing, you could have a distributed load balancer with that, because if a service died, so the lease timed out and it just disappeared. So there was it was actually very natural and very interesting part of Java back then. And a little bit later, I don't know whether you were aware of Jexta. You heard about Jexta, JXTA?
I don't know. I couldn't tell you anything about it.
This was even crazier. So Jexta was like a peer-to-peer protocol in Java, where you had peers, just similar to the Actor model, and they exchange messages. There were even Jexta sockets, and what I did, it was not that. Yeah, it was kind of low level. So we use this in cars, because if cars see another car, you can actually know whether there is traffic jam or something, because there was prior to cellular phones availability, there was a very low level of back, when was it, 2003. So so interesting stuff. So Kevlin, what I would like to do is reinvite you back to a topic maybe which interests me, because I also saw your presentation about 97 things programmers should know about great unit tests and stuff like that.
Yeah.
And I have some ideas from the field which are maybe a little bit heated. So maybe a topic like what makes a good software, or what is a good enterprise software, or where spend time and not time, how to test software, because I get lots of trouble with my point of view, and it would be really interesting to discuss with how to unit test stuff, mock or not mock, system testing, end-to-end testing, and I can provide you some maybe funny or not funny examples from the industry, and this could be fun.
Yeah, I think so. I'd be delighted to come back and continue the conversation.
Oh, thank you, because I also really like your background. Lots of stuff which I didn't knew at all. So and this is why I do actually the podcast. It's fun for me. And at conferences, you have never time actually to speak with people. So at the J Focus, I had I think I spent 3 hours talking to attendees, and at the end I lost my voice actually, and still I had no chance to say thank you for the invitation to the talk 97 things programmers should do. Okay.
Excellent.
Where people can hire you, find you in the internet. So what's your
if you Google Kevlin Henny, it's an internet unique name. You can find me. These days, social media wise, I tend to hang out on Blue Sky and Mastodon, and on both of those, I am Kevlin. So Mastodon, social, and likewise Blue Sky. You can find me on LinkedIn. And feel free to connect with me. Those are probably the easiest places to find me. But yeah, Googling my name will normally take you somewhere.
And what's the name of your company?
The name of my company is Kerbralan. It's not a name I ever use except as it appears occasionally in my emails, or I don't even do anything with the website. But I might rebrand around Kevlin at some point. But yeah, that's just the official name. Yeah.
Thank you a lot. It was fun.
Yeah, likewise.